Good morning. My name is Dr. Smarjit Roy, and I'm a Director of Unity Infra Transit Project Implementers. We have got two other directors, Mr. M.Dhulathsah and Mr. Haris Hasmukh. They are here, but they are busy doing other technical things like taking pictures and sounds and that sort of thing. So, as the name suggests, I'll be talking about some transportation system, and transportation system is very, very important nowadays because every day you hear about congestions, pollutions, air pollution, sound pollutions, and also accidents and non-availability of services. Sometimes bus don't come, train don't come. These sort of things are regular happening. Now, I would like to stress on congestion alone. Congestion was a lot of financial and other inconvenience because it costs money. Simply it costs money. And I'll give you a simple example. Suppose someone is late by 15 minutes due to congestion, and during that time, that 15 minutes, he would have covered maybe 12 kilometers, 13 kilometers. So 13 kilometers I will equate to 1 liter of gasoline. And if you can imagine, there are 10,000 people in any city and any time, then they are wasting 10,000 liters of gasoline for nothing, actually. I say waste on your money, but that is not enough. The government is also losing the money because we import gasoline from other countries. So it's a it's a no-brainer that we are losing a lot of financial and other facilities just because of the proper transportation, and we need to address that. Now you know that there are trains, metros, buses, maybe SkyTrain, monorails, all sorts of things you have seen. But today I'm going to say something about technology which is game-changing in 2015, and it is here. We have done extensive study and found out the best solution for urban area for transportation. And this is energy efficient magnetic levitation train. Energy efficient magnetic levitation train. Now this technology has evolved over hundreds of years, maybe even in 1960s, something like that. They have used it in Japan and other countries, in Germany also. Magnetic levitation is based on magnetic circuit being created, linear motor, and then the magnets are placed in a statistical point whereby it makes the wheel rotate. It's not difficult to imagine because that's how the ordinary ceiling fan or any fan works actually, because you use the magnetic induction for turning anything. So this is not new technology, but the thing that this is a suspended system. That means actually a train and compartment is away from the rail track, and that is a concern for some people actually. Now the thing that but from the positive side, this energy efficient magnetic levitation train, what happens is that there is no contact, so there is less friction, less wear, less servicing. Also, there is no wheels, no axles, no tires. So very few things goes wrong in this sort of system. And so it is energy efficient, and also it is much safe actually. And I'll talk about safety later on, little bit later on. Now, generally, this sort of transportation is about 40% less energy is consumed on this sort of technology because of the type of nature of the thing, because the railway and the buses and trucks are quite heavy vehicles on themselves. They weigh a huge amount of mass on each on them. These things, that train itself is made of aluminum, it's very light aluminum, very strong as steel. And we design on each compartment, so it's only one unit, it's not 7 or 8 coaches, it's just one coaches. As you have seen, it follows one by another. Now, as I said, then there's less pollution, air pollution, there's no pollution at all actually, zero pollution. And there's no noise pollution because it doesn't make any noise by itself. And what we have done is also we have integrated solar technology in it. Solar technology means, we will be using state electricity or government electricity for feeding the service, but we will be producing, generating sufficient electricity ourselves through solar cells. And these are the solar cells you can see. We can place it on top of all the stations and at the end stations like that. We may put the solar panels on that along as well. There's no reason. So we will make maximum use of solar panels wherever possible. And that is not the whole story. There's also, we are adding air turbines. So it is, we are using air turbines to supplement the solar energy. So what is happening that, we are getting renewable energy from solar and air turbines, and it will probably cover all the electricity that we need. At the moment we are working on 17 stations, stretching about 17 kilometer, 17.200 meter exactly, and that will need something like 2.5 megawatts of electricity. But we are very confident that net use will be about the same or thereabout. So it is really, really eco-friendly. Now, one thing I have to again say, the structure of a train or a monorail or a metro is huge, and the cost is huge actually. The cost, I just give you an example. The Meghalab system that we are introducing cost about 50 crore per kilometer, whereas monorail costs 120 crores per kilometer, and metro cost even more. It costs about 220 kilometer per kilometer. So you can see there is a cost effectiveness. It's much cheaper than what you get elsewhere. And another thing also very important, because in this case size matters. Size of the structure does matter actually. And in our case, as you can see, we have got only one piling, which is 1 square meter. That's all you need on the ground space. It's not 2 pilings. It's not huge, 5 meter, 10 meter wide. It's just 1 meter, 1 piling. That supports both north and south actually. That is again unique because it takes very little space. We are using most. The north and south are going on the same rail actually, and it's supported by just one pillar like that. They are, I would say that distance between that should be about 25 meter or so, that is safe. And the height is 15 meter high, from the ground level 15 meter high. So that actually, what happens, it avoids all the cabling and all other things. There's very little things above, above 15 meters. So that avoids that one. So that is very, very useful things to know that we need less space. And doesn't have to be in the middle of the road. Where necessary, you can put on one side, and because it can bend. And talking about the bending circle here is 40 degree on meg level. On monorail and metro is 80. So turning circle is much sharper. It does turn in and out easily. And so that is another benefit. And for safety, we have done a lot of study, and we have designed. It's like a lift, because overcrowding is a problem. Overcrowding is a problem in India, in particular, because if you say it's designed for in a bus, in a case, it will say 50 seats, and there you will find about 120 people standing on there. But in this case, this will be automatically monitored. That means each coach is designed to carry about 60 passengers. So if there is any more than 60 passengers, the train will not move. It is automatic, built into it. It will not move, so it can't go. So it can't accidentally fall off. In any case, this is more secured thing than any other train or monorail system, because it can't actually fall off, because it's not on a wheel. It is on a whole thing is on a bar, so it can't fall off for any. And in practice, in Germany, there is a system going for 100 years. We got details of that, and that didn't have any single accident in last 100 years. So it is very, very secure. Safety is paramount, and it will be designed that train doesn't leave if there is overloading and anything like, or if the door doesn't close, train will not move. So safety feature we have taken very seriously. And what about the running cost? Running cost also, we have done a lot of calculation. We found out that it will be very, very comparable to transport fee you pay. It will cost something like 3 rupees per kilometer at the moment, which is cheaper or equal to almost any transportation that you can get nowadays. All other things, which is environmentally free, it doesn't pollute at all. It's a zero carbon gadget. It doesn't use anything like that. And but most importantly, it needs no service or little service actually, because nothing can go wrong actually. So I think I'll leave it here. I'll just let it run for a minute, and you can see what is happening. And just one more thing I will say: that stations, as we say, are 2 tiers. That means north one is on the first level, and the south one is in the second level, and there will be obviously escalators taking there. There is a parking place behind the station, and people can stand and sit somewhere in a lobby. And it's a similar in when they pick up the passenger from bus stop. This is what we are designed for Puducherry, and Puducherry, the Rajiv Gandhi bus stand will be using that. That is our starting point. So that's where also we have the same facility to 2 levels. First level is going north, and the second level is going south. Car parking area, roads, you can see, it doesn't affect the road at all, because it takes very little post. I mean, in the middle you can see, but that is also not necessary. It's just one single post of 5 meter square, that is all needed. So there you are, you have it, energy efficient magnetic levitation train here, and we are working very closely with a German company. They are expert, they are fully supportive, and they are working with us. They will visit if the authorities want us. They will visit us, and we have very, very positive indication that the finance will not be a problem in such a case, because transport is such an important issue that worldwide we have sounded out, and we get a very, very good response. So it is here, and I'm sure we will be able to implement this energy efficient magnetic levitation train in India very soon. Thank you.
100 smart cities.
ठीक है.